Hello everyone, this is Mr. Kozlowski and welcome to Unit 8 on Chemical Reactions. This is Learning Target number 2, Part A. There's actually 3 parts to Learning Target 2, and this is the first of those 3 parts. Learning Target 2A will discuss a few things. Number 1, we're going to be talking about chemical reactions and how they relate to the law of conservation of mass. Students must understand what the law of conservation of mass is and apply that to specific situations involving the chemical reactions that we're going to be looking at here in this unit. The second thing that students must do is they must identify components of a chemical reaction. What is a reactant? What is classified as a product? And then finally, the third thing that students must do is they must determine the mass of a single product or reactant in the chemical reaction just by simply using simple math skills that we use in chemistry. So what is this law of conservation of mass? You've probably heard the phrase that matter cannot be created nor destroyed. It simply changes forms. And this is basically the law of conservation of mass summarized in basic terms. However, the definition is, in a closed system, the mass of the reactants is always going to equal the mass of the products. And this is true in terms of 3 things: the number of atoms, the mass of the reactants versus the mass of the products, and then also the elements themselves and the types of elements that we have. Now we're referring to a closed system in this case because in a closed system we know that energy is not going to leave or enter, so is matter. It's going to stay basically the same throughout the whole reaction itself. So we like to assume that when these reactions are occurring, they're occurring in a closed system. So in a chemical reaction, one of the things we have to identify in order to understand the law of conservation of mass is we must know what a reactant is versus a product. Well, a reactant is basically what causes a chemical reaction, and a product is the result of a chemical reaction. And in both of these things, we're going to have to understand what the number of atoms are, the mass of the reactants, and then also the types of elements that are both in the reactants and products. For numbers of atoms, this is going to be the equation for a chemical reaction. We have to understand that it's going to be a balanced chemical reaction. And we're going to actually balance chemical reactions later on. That's going to be a separate learning target because there's so much that goes along with that. Obviously, the mass of the reactants is equal to the mass of the products. So what we start with in terms of the reaction, in terms of mass, is must equal at the end. The mass must be equal to the products as well. And then finally, the elements are the same. Atoms for each element are rearranged in a chemical reaction. Understand that in a chemical reaction, the elements stay the same throughout. The types are the same on both sides. However, there is a rearrangement of the elements that must take place in order for the chemical reaction to occur. So, in a chemical reaction, what do we need to know about the equation? And what we're going to look at today is a common equation called photosynthesis. And photosynthesis is the reaction of where sunlight and water and CO2 are taken in by a plant. And that's converted into sugars and oxygen to basically help the plant survive and provide food for itself. So what is a reactant versus a product? Well, if we look at the equation of photosynthesis is written out here. Carbon dioxide plus water is going to yield, that's what the arrow means, it's like a big equal sign, glucose and oxygen. In chemical formula speak, which we're going to use, that's 6 CO2 plus 6 H2O is going to yield C6H12O6 plus 6 oxygen molecules. This is important. This is important because these are the reactants, these are the products. So what we start with again in a chemical reaction are the reactants. The reactants in this case are CO2 and H2O. The products are what is left over from the reaction or what is made from the reaction. In this case, it is glucose, C6H12O6 plus 6O2, which is oxygen. So again, products are the results, the reactants are what we begin with. Now the other thing that you have to understand with this is you have to be able to balance or determine that the number of atoms on both each side of the equation must be balanced as well, meaning they must be equal. And to determine this, you have to understand what a subscript is versus a coefficient. And again, we're going to balance more towards later in this learning target, but I just want to introduce subscripts and coefficients to you. A subscript is actually something that you've been dealing with your compound writing. If you look right here, C6H12O6 is glucose. That means that in this molecule, we have carbon, hydrogen, and oxygen in these specific ratios, 6, 12, and 6. So we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms that chemically combine to make up the formula for glucose. This obviously is a product, but basically the subscripts are going to tell you how many of each atom you're going to have in that specific compound. So H2O, I have 2 parts hydrogen, 1 part oxygen to make up a molecule of water. Speaking of molecules, that is the purpose of the coefficients. Coefficients are the larger numbers in front of the chemical formula for each compound. So what this is saying is, if we look at the reactant of CO2, carbon dioxide, we have 6 molecules of CO2. So coefficients tell you how many molecules are needed. And they will tell you work for both ends of the equations, the reactants versus the product side, and they also play a big role in balancing chemical equations. So you'll use coefficients and subscripts a lot in order to balance equations later on in this unit. Finally, in terms of the mass of a chemical reaction, again, the reactants must equal the products in order to observe the law of conservation of mass. So in this case, we have the photosynthesis reaction again, and my question that I'm posing to you is, what is the mass of O2, or oxygen? Well, we're going to need some information to calculate that, and what I've given to you is let's assume that here are the masses of those products and reactants for this chemical equation of photosynthesis. So let's look at the reactants first. We have 2 reactants, one of CO2, which is equal to 5.03 grams, and then we have H2O, which is equal to 7.45 grams. So those are reactants. So basically, we know that in the law of conservation of mass, that the reactants must equal the products in order to be observed. However, if we look at the products, since we have the reactant side, but we look at the products, we are missing one in trying to calculate for O2 on the product side. But we do have the value for glucose. And basically, the value is 9.62 grams. So if we look at that and we do a simple calculation, all we really need to do in this case is solve for the unknown. And if we look, we have this CO2 plus water plus glucose. We have all that in terms of the mass. However, we do not have the mass of O2. So what's left over? Well, we have to do simple math. So what we would do in this case is we're going to add the reactants. So we would add 5.03 grams of CO2 plus 7.45 grams of water, and you're going to get a value that should be larger than 9.62. And what we do when we're ready to go, we take that and we subtract 9.62 grams from this value. That will give us the mass of oxygen. In this case, when you plug in the numbers, you should get a mass of oxygen of 2.86 grams. So that, again, to calculate the mass of products versus reactants should be fairly straightforward once you get an understanding of, okay, reactants, products. Reactants are what we start with, products are what we end with. If we know the masses of 2 of those, we should be able to calculate the 4th one that's left over using simple arithmetic skills. So with that being said, what do you need to do for 2A? Basically, students will, again, need to understand what the law of conservation of mass is. They need to be able to define it and then also apply it to new situations. How are they going to apply that? Well, again, they must identify components of the reaction. What are the reactants? What are the products? And then finally, they need to determine the mass of products and reactants in a chemical reaction. They're going to have to do similar problems to the one that I addressed in this lecture on their quizzes and also on their tests as well. So again, this is Mr. Kozlowski. If you have any questions, just take good notes, and then we'll review this in class once we get back. Thanks.